Good morning. Today we'll be continuing with integration using substitution. We have already considered the method of doing integration using substitution and also considered a very important application of this, that is we get to know the integral of tan x, we get to know the integral of cot x, sec x and cosec x dx. Okay, and these results you can add in your already formed list of various integrals. Okay, and slowly we'll keep on adding more integrals and more results to that same list. So we know that integral of tan x is log sec x, that of cot x is log sin x, that of sec x is log of sec x plus tan x, and cosec x is log of cosec x minus cot x. These results and their derivations we had done in the previous video. Now let us continue with the exercise 7.2. We have already discussed first two questions in the previous video, so we will be starting with the third one. But let's do a quick recap of what is required to be done in these questions. We will first have to look at that function whose derivative is a part of the numerator which comes in product with dx, and that's how we make the substitution. So let's see how. Question number 3. First and second we have already discussed in the previous one. Question number 3 says 1 upon x plus x log x into dx. Now apparently just by looking at this we can't do anything, because this function being in the denominator you can't split it. So we have to first factorize it. And how do we factorize it? You can take something common. So what do you get? We can take x common, we'll be left with 1 plus log x into dx. Now if you observe carefully, if we put this entire thing in the brackets to be t, its derivative would be 1 upon x dx, which will be a part of dt. Now here you could have put only log x also as t, but in that case you will have to apply substitution twice. So though we can still continue doing it, but it will be much longer. So what we do is straight away put 1 plus log x as t. Since the derivative of 1 is 0, so directly we get, so differentiating we get only 1 upon x because of this into dx equal to dt. So we observe that if you put this as t, 1 upon x dx gets absorbed in dt, and so we get I becomes equal to dt over t, whose integral we know is log of mod t plus c. Again we can't leave the result in t because t we have brought in, and so replacing back t we get log of 1 plus log x plus c as the result. So with substitution these questions which look very difficult become very easy to handle. Now similarly, now let's take question number 4. In question number 4 we have I is equal to sin x into sine of cos x into dx. Now here it's a part of it involves product of two functions. One is sin x and one is sine of cos x, which is a function of a function. And we are already aware that mostly what we do is, if we are given a function of a function, the inner function we assume as t. That's the first thing which should come to your mind, that the inner function has to be assumed to be t. Secondly, we also observe that its derivative should be available here, which is there, because if you put cos x as t, we get minus sin x dx as dt. So clearly this sin x gets absorbed in dt, and so we can write it very easily as, in place of, this is sine as it is, and in place of cos x we write t, and then this sin x cos x sin x dx gets replaced with minus dt. So you get dt and minus comes here. Now integrate sin t. Integral of sine is minus cos, but one minus is already there outside, plus c. So this minus gets cancelled with this minus. Now again replace t in terms of x. We get the answer as cos of. Now t was cos x, so you get cos of cos x plus c, which is the answer. Now let's take the next one, which says that sine of ax plus b into cos of ax plus b into dx. This has to be evaluated. Though this question is similar to this one, but here both are functions of a function. Like here also you have sine of ax plus b, and here also we have cos of ax plus b. Now you could do it in two different ways. One is that, as I have already told you, you put this inner function as t. So what do you get? Ax plus b as t. We get a dx as dt. I becomes equal to sin t cos t, and in place of dx you will be writing dt by a. Now either you use replace this by sin 2t upon 2 and then do the needful, or we have to make substitution again. So here this involves substituting twice. So we will look for that function whose derivative is already present and assume it to be something else. So let us put sin t as u, so that we get cos t dt as du. So I becomes 1 upon a was already there. Sin t is u, cos t dt becomes du. You replace, you solve it, you get 1 upon a u squared by 2 plus c. Now replace u in terms of t and then t back in terms of x. So what do we get? 1 upon 2a. In place of u we will write sine of t plus c. Now t also we have brought in, so we have to remove this also. So we get 1 upon 2a sine of, in place of t we will write ax plus b plus a constant. This is the answer. So we can do it using this method, but here we have to apply substitution twice. Instead, another way of doing it is, now here directly we can put, or how do we do? We know that sine of ax plus b and cos of ax plus b are derivatives of one another. So any one entire function we can assume to be t. So we can put sine of ax plus b as t. Now when you differentiate, what do we get? Cos of ax plus b, you apply chain rule here, into derivative of ax plus b is a. So you get a cos ax plus b into dx is equal to dt. So clearly this whole thing, cos of ax plus b into dx gets absorbed in dt, and so I becomes equal to, now we get sine of ax plus b is t and cos of ax plus b dx is dt by a. This comes out to be 1 upon a t squared by 2 plus c, or I becomes equal to 1 upon 2a. In place of t you replace sine of, this is also here square. Now you get sine squared ax plus b plus c. You observe that both the answers are one and the same. So here you have to act wisely, though we are using substitution, but instead of applying substitution, going by the very basic and doing all the steps, you can just skip out this one full step or 2-3 steps by directly assuming this full term to be t, and still we get the same answer. Okay, now let's take the next question. Similarly, 6th can be easily done. It's again a direct application. Let's take question number 7. We get in question number 7, it is I is equal to x under root of x plus 2 dx, which can be written as x plus 2 raised to the power of half into dx. Now here you can't open it directly because of the presence of exponent half present over a binomial. Okay, so our idea is to shift this power from the binomial, that is two terms, sum of two terms, to a monomial, which is a single term, so that we can apply the distributive law. So here again the inner function we will put as t, so that we get dx equal to dt. I becomes equal to, here this is t raised to the power half. Now dx is dt. Now again there is a presence of x here, so from here we can write also, we get from here x is equal to t minus 2. So you write here t minus 2 for this x, and this x plus 2 becomes t. So we get t raised to power t raised to power half is this term, t minus 2 is in place of x, and here in place of dx you write dt. Now since the power has been shifted from a binomial to a monomial, means from two terms to single term, you can easily apply distributive law and expand it as t raised to power 3 by 2 minus 2 t raised to power half whole into dt. Now apply the integral directly. Integral of t raised to power 3 by 2 is 3 by 2 plus 1, which is 5 by 2 upon 5 by 2 minus 2 t raised to power 3 by 2 upon 3 by 2 plus a constant. I becomes equal to 2 by 5 t raised to power 5 by 2 minus, this becomes 4 by 3 t raised to power 3 by 2 plus c. Now again, since t we have introduced, we have to replace it back in terms of x. So this becomes 2 by 5. In place of t we write x plus 2 raised to the power of 5 by 2 minus 4 by 3 x plus 2 raised to the power of 3 by 2 plus a constant. Similarly, we can do question number 11, which says that it's exactly on the same lines. It is x upon square root of x plus 4. Okay, so if you observe carefully, here also the power is over the binomial and not over the monomial. So what we do? Exactly on the same lines. Okay, so put x plus 4 as t, we get dx equal to dt, and from here it is, now from here we can get x is equal to t minus 4. So I becomes equal to t minus 4 into dt. X is t minus 4, dx is dt, and this becomes t raised to the power of half, which can be written as t raised to the power of half minus 4 t raised to the power minus half whole into dt, which can be easily solved. And so this becomes you apply the integral, you get this becomes 3 by 2 over 3 by 2 minus 4 t raised to the power minus half plus half, plus 1 is plus half upon half plus a constant. I becomes equal to 2 by 3 t raised to the power 3 by 2 minus 4 into 2 half plus c. Now replacing t back in terms of x, we get 2 by 3 x plus 4 raised to the power 3 by 2 minus 8 x plus 4 raised to the power of half plus a constant. Now let's take up question number 10. It says that I is equal to 1 upon x minus root x dx. Now if I put the whole thing as t, then its derivative is nowhere present here, nor can we simplify it further. So here again what we do is, we can't split this denominator, so let's try to take something common if it's possible. So what can be taken common? Very clearly you can take root x as common. You will be getting it as root x minus 1 dx. Now if we put this thing as t, we will get 1 upon root x dx gets absorbed in dt. Let's see how. Put root x minus 1 as t. This gives us 1 upon 2 root x dx is dt, and so we clearly see that this gets absorbed in dt, that is 1 upon root x dx is dt, 2 times dt. Okay, so what do we get? I becomes equal to, in place of root x minus 1 we'll put t, so that is in the denominator. This becomes 2 times dt. Now the integral we know 2 is as it is, and this is log of mod t plus c. Replace back in terms of x, so what do we get? 2 log root x minus 1 modulus plus c, and this is the answer. If you want, you can make this 2 come this side, and this will become log of root x minus 1 whole squared plus c, applying the properties of logarithms. Okay, now coming to the next question, that is question number 12. We see that I is equal to integral of x cube minus 1 raised to power 1 by 3 x raised to power 5 dx. Now if you just see, it is a product of two functions. This one is a function of a function because there is one polynomial and raised to the power of 1 by 3. Now apparently there seems to be no link between the two functions. Like if you if you look at the question, usually the inner function we assume as t. So let's first take up x cube minus 1 as t. Let's see what do we get. We get 3x squared dx as dt. Now observe carefully this function. Though there is no direct link which appears between this function and this function, but here if you put x cube minus 1 as t, you are getting something x squared dx as dt. Now here this x raised to power 5, can we write it as x cube into x squared? Because how can we write this? This can be written as, you can write this as x cube minus 1 by 3 x raised to power 3 plus 2, which can be written as x cube into x square into dx. If we write like this, and then if we put x cube minus 1 as t, what do we observe? This we have put as t, this gets absorbed in dt, and this can be written as x cube is t plus 1. So everything gets taken care of, and so I becomes equal to, in place of this we'll write t raised to power 1 by 3. In place of x cube we will write t plus 1. In place of x squared dx we will write dt by 3, and this is integral. So now 1 by 3 comes outside, and this, since the power is over a monomial, that is a single term, and this binomial is with power 1, you can easily apply the distributive law. So t raised to power 1 by 3 into t is t raised to power 1 by 3 plus 1, which is t raised to power 4 by 3 plus t raised to power 1 by 3 whole into dt, and whose integral can be easily found out. T raised power of 4 by 3 plus 1, 4 by 3 plus 1 plus t raised power 1 by 3 plus 1, 1 by 3 plus 1 plus a constant, and so we get I is equal to 1 by 3. Now this becomes 7 by 3. So 7 by 3, which becomes, you have to write the reciprocal, 3 by 7 t raised power 7 by 3, plus this becomes 4 by 3. So t raised power 4 by 3, and you have to write the reciprocal, so 3 by 4 plus c. Now if you just see, this 3 gets cancelled with both these 3, you get 1 by 7 t raised power 7 by 3 plus 1 by 4 t raised power 4 by 3 plus a constant. Now replacing back t in terms of x, we get I is equal to 1 by 7 x cube minus 1 raised to the power of 7 by 3 plus 1 by 4 x cube minus 1 raised to the power of 4 by 3 plus a constant. Now let's take the next one. Again, question number 13. Now each question, if you see, they are similar, but yet they have something typical about them which you have to be very careful about, and for this you need to practice a lot. The more you practice such kind of questions, the easier it will be for you all to handle these questions. Okay, now question number 13 says I is equal to x square over 2 plus 3x cube whole cube dx. Now again, it's a quotient of two functions, out of which the denominator is a function of a function. So by default we'll put 2 plus 3x cube, that is the inner function, as t. So what do we observe? We get 9x square dx is dt. So what do we observe? This x square dx gets absorbed in dt, and so we get I is equal to, this is dt by 9, so 1 upon 9 into dt whole upon, in place of this we are writing t, so t cube. This becomes 1 upon 9 t raised power of minus 3 dt. Now apply the integral. What do we get? 1 upon 9 t raised power minus 3 plus 1 upon minus 3 plus 1 plus a constant 1 upon 9 t raised power minus 2 over minus 2 plus a constant. Replacing back in terms of x, what do we get? Minus 1 upon 18. T is 2 plus 3x cube raised power minus 2 plus c. Either you leave the answer like this, or you can write it as minus 1 upon 18 2 plus 3x cube whole square. 18 times this plus a constant. Either ways you can leave the answer. Okay, and I'll just take up one last question for today, and that is question number 14. It says that 1 upon x log x raised power m dx. Now again, this is a function of a function, so by default we have to take the inner function as t, and also we have done a similar question earlier that log of x, the derivative is 1 upon x. So when you put log of x as t, its derivative is 1 upon x, dx is dt. That is, this part gets absorbed in dt, and so we get I comes out to be dt over t raised power of m, which is similar to this question, that the power goes to the numerator and becomes negative. So you get minus m dt, and you solve it, you get t raised power minus m plus 1 over minus m plus 1 plus c. Replace back in terms of x, you get 1 upon minus m plus 1, or into t is log x raised to the power of minus m plus 1 plus a constant. You either leave the answer like this, or you write it as this becomes 1 upon 1 minus m, can be written like this, into 1 upon log x. Either you write in the numerator 1 minus m, or when it goes to the denominator it becomes m minus 1 plus a constant, and that is the answer. Thank you.